All right, in this part, we're gonna start tweaking the terrain by converting it into a mesh. So we're gonna use a convert height field. Yep, so it's taking a bit of time to cook, but yeah, now we got a proper mesh. Wonderful. Of course, we can hide the rest. That will help a bit. And the density, you can change it basically if you want like faster display. It's probably a good idea to reduce that around 0.2 at the beginning so that we can iterate a bit faster. So I'm dropping a point VOP, and we're gonna do some operation in there to deform all those points, and yeah, let's get going. So we're gonna use the position and convert it into a float to extract the different axes. So I'm plugging that back into a float to vector, so nothing changed in that case. But as soon as we add, let's use the z-axis, and we're gonna add a constant. As you can see, well, first let's call that display z, and let's go back to the root. We have a parameter, and if we like change this value, we are basically doing a translate z. So it's pretty simple. Now, using this principle, we're gonna use the relative to bounding box. As you can see, we got a pretty colorful kind of display, and what it's doing, it's basically creating a gradient based on the bounding box information. So we're gonna use the second output, which is based on the y-axis, and we're gonna multiply it inside this display z. Now, what it's doing is, if we try to tweak the displacement, it's gonna kind of distort it in that direction. So I'm gonna use a negative value in that case, and we got this pretty graphic kind of rock formation now. Oh, that's a lot of fun. I'm gonna make some room, and we're gonna improve a bit this setup. We're gonna add some turbulence noise. Let's remap its value with a fit range. I'm gonna move that here, and let's check out its color. So right now the frequency is like way too high, so we should decrease it and start to see some noise pattern. Let's promote this parameter so that we can access it from the point VOP root, and same goes for the fit range. Let's expose that. Now we can access all those parameters from here. That's good fun. All right, and this basically will drive the breakups. So all we need to do is to create a mix node, and let's plug the multiply that we had here, and we're gonna plug the noise into the mix amount. So for the mix other input, I'm gonna multiply the value we had by 1 so that it goes to the opposite direction. So now we got kind of a pretty weird result, but why not? Kind of thinking the scale might be not large enough, so we should reduce that and maybe try a different noise, like noise purling. So we would need to adjust a bit the contrast and stuff like that. Probably decrease the roughness so we get larger patterns. Yeah, actually, like using the opposite directions probably not such a good idea, so let's just multiply that by 0 instead. So everything's gonna switch between this and this position. So as soon as we increase the turbulence, it's gonna distort it. Okay. So we're gonna have to reuse this node quite a bit. So let's organize it a bit more and clean the names. So min input, max input. And let's drop a folder and drop all the noise parameters inside. And also the min and max input that will control the contrast. And that's the final output. Okay. So we could also add a controller to enable the color of the noise, like if we want to check out what this noise looks like. So this will be a checker box that we're going to call this noise. And let's copy this parameter, and we're going to create a switch node. Let's plug in the first input the color, the CD attribute, and in the second one, the turbulence we created, and pass the relative reference. So we are exporting that into the CD attribute. And now, as soon as we enable this checkbox, we can visualize the turbulence noise. So that's pretty handy. All right, I'm gonna stretch a bit this noise, especially in Y. And also we can copy this X parameter and pass it into the Z frequency, so that we just need to change the X axis. And let's see, if we increase the max output, yeah, it's looking all right, I guess. Let's try some bigger frequency. Okay, I'm pretty happy with that. We get some areas that are very steep, some that are more inclined. So yeah, that sounds good. One thing we could also do if we want is bring some deformation into the x-axis. So we could do the same and just bring some deformation based on turbulence on that guy. And we would have, in that case, the cliff going in this direction. So that might be a little weird, but maybe there's something to do with that later. Let's rename that point up slope distortion, something like that, and apply a little color too, a green one. So we're gonna create a new point up, this time to get rid of the points that are on the ground. Just wanna keep the cliff shape. So I'm then again using a relative to bounding box node, and we're gonna extract the y-axis to extract the height of the model. And then we're gonna use a compare node so that we can compare the value of the y-axis with a custom value, in that case 0. And we're gonna export the result into a two ways, which means that based on this comparison, it's gonna export a value. In this case, this value is gonna be based on the point number. So which means this two-way node is gonna export all the point numbers that are greater than 0 and remove them with the remove point. As you can see, if we increase the compare to float, well, right now there's a little glitch. I need to change context and come back. Yeah, now it's updating. You can see that we are deleting all the points greater than 0. So we need to change the sign and precise less than. And now we just keep the cliff. So that's perfect. We're going to expose this parameter so that we can just change this value from the top level. And we're going to rename this height threshold. And we're going to call that delete points. Let's change a bit the density to see how it looks. And if we reset that to 1, we see that we got a clearer shape already. So that's pretty nice. Okay, and let's redisplay everything. And yeah, I think that will do for now. I'm gonna reset the density to 0.2 for now. So I'm actually gonna call that point up cliff distortion, and edit some parameters in there, like the name of this folder. Let's actually call that noise setting, and maybe create another folder for the remap so that there is no confusion. So that's a simple folder, and let's call that contrast. Maybe one more folder for the final outputs and main controls. So displays Z is gonna go in there too, and we're gonna call that displays control. That would be actually max displays. That would be minimum noise influence and the maximum noise influence. I think that's a bit clearer than the min max output, you know. Okay, so in that case, a value of 1 is resetting the noise, so we might need to change the input into the mix so that it makes a bit more sense. Yeah, like so, just swapping these inputs. And now if we set that to 1, it's gonna distort the model. So that's great, it makes a bit more sense. I'm gonna play a bit more with the noise. I think we could make that look a bit better. Probably the frequency is too large too. And yeah, something like that maybe. Let's see. Yeah, bring some nice variations, I think. Okay, now we're gonna create another layer of distortion. Let's copy this node and paste it. And we're gonna dive inside. So in there, we're gonna disable the add into the z-axis, and we're gonna instead enable it into the x-axis. So in that case, we're gonna reset the opposite direction to -1, so that we got deformation into both direction. So in x and -x. I'm gonna remove a bit of roughness. Let's see. Yeah, like we don't want everything to be straight, so I'm thinking that can be a nice touch to add. Then we see that it's creating some intersection. We'll have to fix that at some point. But for now, my concern is mostly about having some cool inclination on those cliffs, and if it looks too straight, it's not gonna feel too natural. And I think having some kind of distortion like that could really help. Let's reset that to 1. So okay, we definitely have some intersection that we'll need to get rid of. And yeah, let's visualize the noise a little bit. I'm gonna try to reduce the contrast. Maybe that can help with the distortions. And maybe change to something like a simplex noise. So we need to reset a bit the contrast and play a bit more with that. Yeah, it's not changing too much, but well, the effect is still here, I guess. All right, maybe something like that. Actually, more contrast could help. So with, without, yeah, that's pretty subtle, I think, right now. All right, one thing we haven't considered yet is having a beach or like a area in the bottom of the cliff where we could scatter some rocks and stuff like that. So we're gonna go back to the main height fields and copy the secondary breakup layer. All right, let's make some room and let's call that, I don't know, beach cliff layer, something like that. I'm gonna move this so that we can have a bit of room, and let's duplicate this height field layer and plug this output. So now we're gonna play with the controls we created before, and I'm gonna lower the height of these guys. So still got a little glitch, that's better. And yeah, definitely lower this terrain so that we got an area that could represent the beach. So of course we need to extend it a bit more, otherwise it's gonna overlap with the second layer. As soon as we extend it, it's now creating some more interesting breakups. So if this is a beach, it's still a bit high, so let's reduce the height multiplier. And yeah, that feels a bit better. Maybe we could check out with the water how it looks. And I'm thinking my water layer is a bit too high too. So let's reduce that. Okay. We could also play with the distortions, of course. We're gonna offset that so that it doesn't perfectly match the second layer. I'm playing a bit with the roughness. So maybe I'm gonna play also with the blur. Yeah, so that we got more like some inclination going on. So from there, it's just a matter of playing with all the controls we already created and find something that works like for you. If you have reference, of course, it's better. I'm actually like having a look at some cliff photos on my side. So you should probably do the same and try to fit whatever you're making. Right. So actually, I'm going to duplicate the mask expand, and I'm going to create a second one that we could mix together, just so that everything is not at the same kind of level of expansion. So blending that with another mask noise. Yeah, something like that, maybe. I mean, it's not probably super helpful. I don't know. We can maybe add a bit of breakups, but maybe something like that. Okay. That can maybe be interesting. We got some shapes a bit more subtle, I guess. Let's display the water. And yeah, maybe play with the element size again of this mask. No, that's pretty interesting. Let's check out how it looks in the end. So we can notice that some height field we could actually mask a bit of noise. There's something missing a bit the result, and that would be this initial height ramp. We could yeah, reduce that so that it's not affecting the beach. So how it looks in the end, I think it will add some interesting features on this cliff. So yeah, definitely help selling the cliff look. And actually we could also create a mask noise on the mask input of this guy, if we want to bring variation in terms of height. Yeah, see, already it's creating some more height variations. And depending on how we set this mask, it's gonna create more or less beach. So some areas are like completely flat, some you got a bit of beaches, so that can be pretty interesting. Let's call that beach. Okay, let's actually plug that here. It's a bit clean. And yeah, I think we are good to go. Let's see how it looks in the end. So that's the final mesh. Pretty cool. All right, from here we're gonna work on the underwater ground, and we're gonna extract a mask based on the height. So another mask by feature, and let's disable mask by slope and enable mask by height and compute range. Let's delete those, and we're gonna try to isolate the ground. That's like so. So from here we're gonna use a shrink mask so that we have the depth gradually getting deeper if we get away from the cliff. So let's increase the radius, and it looks a bit messy, so we want to blur it so that we get this nice smooth slope in the end. When you get far away from the cliff, it's gonna get deeper. So let's use a height field remap, and yeah, let's not forget to plug the mask and decrease the output mean. So okay, right now we see how the underwater is looking, so it's going deeper. And we're gonna add a height field noise to bring some breakups to this flat surface. Okay, let's plug the mask as well. And let's play with our best friend, amplitude and element size. So something like that. Actually, I'm gonna plug the mask input in here. And how would it look with more amplitude? Okay, we definitely see some noise that are going above the ground, so that's not good. Probably should also change the combine method at some point. It's gonna decrease the roughness for now. Don't want something too detailed. Okay, let's create a network box for that. It's gonna be underwater. And let's plug that. So what do we got in the end? So the remove points is, it first seems that it's not cropping anything, but it does. The thing is, we use the relative position based on the height of the model. So 0 would be the lowest position into the model. We actually would rather use the absolute position, which is the P attribute. So let's remove this relative bounding box. And now if we set that to 0, it will be based on the world space. So let's see with the water. Yeah, that's all right, but we still have a bit too much kind of noise that are elevating our initial terrain. So let's actually go back to this height field noise and change the combine method to subtract. So instead of adding noise, it's gonna subtract it. So let's re-enable the delete points, and now it's actually looking more closer to what we had before, these all ground operations, which is good. If we check out the water, yeah, that will do. Okay, I'm gonna leave that to 0, and we're gonna duplicate this delete point, and we're gonna extract the underwater. So let's just change the sign to greater than, and now it's isolating the underground. Let's pass the relative reference so that if we change our main delete point, it's gonna affect the other one. So as you can see, we got the model split in 2 parts, so that's great. And why is it so great? Well, you'll see in the next lesson.